Hi, so in this video I want to show you one frequent way that I use to distribute computations in a scalable way. I often get questions about, well, can you create a video on sub-processes so I can scale my application in Python? And the short answer is I don't use it because it's not scalable enough. What I mean by this is if you have a problem in Python that you're trying to solve, and of course, Python is inherently single-threaded, which means your Python app is going to run on a single core. And that's not sufficient. You need to distribute your work across multiple cores or across multiple CPUs. Some people think threading is the answer to that, and of course it's not. Since Python is inherently single-threaded, for computational work, multi-threading is not going to speed up your application whatsoever. If you're I/O bound, basically your program is basically running slow because it's waiting for something to happen, it's waiting for some I/O operation, maybe an API call or a call to a database, what have you. Then yes, threading can help, but it's much simpler to use async. So I don't use threading either. Basically, the only thing that I use in Python is either going to be the asynchronous processing or this technique that I'm going to show you here, that allows me to distribute work across more than one computer. Because if you write your application using sub-processing, yes, it can scale up to the number of cores that you have in your computer or the number of CPUs, but what happens when you grow beyond that? Then you need to basically rewrite your code to handle things differently. And it's really not difficult to write the code to start off with to be completely distributed, as opposed to being limited to a single computer using the sub-processing. So the idea is very simple. Basically, I'm going to use a queue, a message queue. And here in this video, I'm going to show you how to use Redis. But there are lots of other message queue platforms as well. For example, this RabbitMQ and SQS, which are two of the ones that I use the most often. You have others as well. You have ElasticMQ, which is similar to SQS. It has the same API essentially. And you also have Kafka and a bunch of others, and I don't really know them well. The three that I know well are Rabbit, ElasticMQ, and SQS, and of course Redis. So the idea is that we have our main application. This is the one that's running slow because it has to do all these computations. And remember, this is now something that's computationally bound, not I/O bound. So it's computationally bound, and it's just not working fast enough. So what I need to do is I need to write my application so that I can have concurrent work happening. And the concurrent work is essentially going to be defined by a message in the message queue. That message is going to contain all the information that it needs for another application to look at that message and perform the work that's needed. So the main application essentially just pushes messages to this message queue. And then we have a worker application that's running independently that picks up the messages from the queue and processes them, and then does whatever it needs to do with it. Maybe it writes it back to a database, maybe it writes it to a file system, maybe it pushes it to another queue, whatever your application needs to do. So the advantage of that is that now we can run multiple worker applications. We could run the worker application on the same computer as the main application. We could run the worker application multiple times on the same computer where our main application is running. That's what sub-processing would give us. But now we can start running these worker applications on other nodes, on other computers in our network. And they can all be working, pulling messages and doing that work. So this is very, very scalable. You can start with a worker application or a couple of worker applications on a single computer, or you can start distributing your worker applications across multiple computers. And so this is why I don't use sub-processing. I use this approach over here. Now, there is one thing that's really important to understand here, is that when you're dealing with concurrency problems, one of the key things usually when you're working in with concurrent work is that the order of execution should not impact the final result. That's really, really important because there's no guarantee that even if you use what's called a first in, first out queue, like a FIFO queue, the worker applications will pick up the messages in that order. That's true, that's right. But when is the worker application going to complete its work? There is no guarantee of the order in which that worker app will complete its work. So you need to make sure that however you write your program, your application, it is not dependent on the worker apps processing the data in the same order as which it was pushed to the queue. So as long as you have that, this method over here works. So if you look at the README file, I explain, an example of where I've actually used this in a concrete way. It was for image processing. I'm not going to get into that. You can read that if you want. There's a lot of extra text in the README that you can read. So as I said, there are many queue platforms that would work very well for this. And my most frequent go-to is RabbitMQ. Slightly simpler to set up would be SQS, I also use ElasticMQ. If I'm going to use SQS, then to test things locally, I'll use ElasticMQ, but you can also use that in production. But there's many other message queue platforms as well out there that you may already be familiar with, like Kafka, ActiveMQ, and so on. So here what I'm going to do, though, is I'm going to use Redis as a queue, and I'm going to use a Redis list. Now, it's simple enough, and it comes without the additional complexity of the other options, but it's not 100% foolproof. And the reason for this is as follows. Let's say that we have this queue, this list, and what we're going to do is the main application is going to push items to the queue, and then the worker applications are going to pull items from the queue. Now, what's important about queues is that if you have multiple workers running, you don't want, different workers to pull the same message. And this is where things like RabbitMQ and SQS and so on, work. They basically guarantee that. And actually, Redis does as well. So that's not the issue. The issue is what happens when a worker pulls a message from the queue. It's now been removed from that Redis list. But before the worker can complete its work, it crashes. And it doesn't actually finish processing that message. That means that we've lost something. So if you need to be resilient to message losses, then you're going to need to kind of expand on what I'm going to explain here if you're going to use Redis. If you're using Rabbit or SQS, that comes built in. And that's why, in part, these systems are a little bit more complex. Now, if you want to solve that problem in Redis, there is a way to do it. It's a little bit more complicated. You have to set up another queue, and there's other things that you need to do, which I'm not going to cover in this video. I will at the end of this video and at the end of this README, there's a link to the Redis documentation on how you can work around that problem in Redis if you want to do that. But if I'm going to get to that point, I may very well then switch to SQS, for example, as a first step. And if I find that insufficient, then I might go over to something like RabbitMQ. So if you're interested, just leave something in the comments saying that you want me to cover that. And if there's enough interest, I'll cover how to fix this problem in Redis if you want me to cover that, or maybe how to use Elastic or SQS or RabbitMQ. Please don't ask me about Kafka and the other ones. I don't know them, but I do know those ones. So if there's enough interest, let me know in the comments and I can do a future video on that. So given all this, we're going to use Redis, and we are not going to solve the problem of potentially losing something if the worker application crashes. Okay, so let's switch to code and let's actually start coding this up. Okay, so this is the start of our application. I've actually already created my Python virtual environment. I used pipenv, but I have the requirements.txt file in the code that's in the GitHub repo. It's linked below this video, and that's already basically set up. But let's go ahead now and look at the first thing. First thing I need is Redis. So I'm going to use Docker for that. And this is my Docker Compose file. So I'm actually going to use Docker Compose. And I'm going to use the Redis image, which comes from Docker Hub. And it is basically over here. You can search Docker Hub for Redis. This is the official image. And it tells you all the different versions that are available, the tags and so on, and how to use it. And basically, it tells you a little bit of information on how to run it. So if you want more info on that, it's available there. But this is my Docker Compose file. I'm going to expose the Redis port on 6379, and I'm going to save every 20 minutes. You can change that however you want. I'm also going to require a password. The password is going to be secret. Obviously, when you run this for production, you're not going to set things up this way. You'd never have this, for example, in your files. You don't want to put that into your Git repo and basically expose your password anywhere. But for this video, that will be good enough. So we're going to run Redis. So let's go ahead and open up a terminal window. And all I need to do here is say docker compose up. So it's going to take that file and it's going to start Redis. And so here we go. Redis has been started. It is running. Now, I will show you later how to query Redis from the command line. But right now, this should be empty. And we're going to start running our applications. So let's create a directory. The first one I'm just going to call app. That's going to be our main app. And I'm putting all this under the same project, but it could be under different projects as well. But I'm just going to do both here for simplicity. And then we're going to create another application within this called worker. And then each one of those can have the requirements. Now the requirements, let me just copy paste that from the code. And as I said, I've already installed it, but you'll need to install Redis. Basically, all you need to do is install Redis. I've basically limited it to 4.5. That's what I'm using right now. Just in case something changes later, at least we have something that's more consistent. In practice, you'd probably pin it down to a specific version when you're putting things in production. So here, I'm going to use this library for communicating with Redis. And that's really all I need. And then I need the same thing technically, since I'm thinking of this as separate applications, I would need to put it under that one as well, right? So I would have the requirements in both, and then I would have virtual environments for both, and then I'd be able to run the applications for both separately. Because remember, this worker is supposed to be running on any computer. Okay, so now that we've got Redis up and going, let's go ahead and write the main application. So the first thing I'm going to do is I'm going to create a config.py. Again, I'm keeping things simple. In practice, you'd probably be using things like environment variables. And then in your CI/CD pipelines, you might actually, basically put those in. So here, though, I'm just going to hard code everything in here. Again, not a good practice to do that. Certainly not for the password. The other things might be okay. So what are we doing here? Well, we have to specify our Redis host. I'm running it via Docker, and I've exposed port 6379, right? So it's running on my local machine, and port 6379 has been exposed. So I'm going to use localhost for the host, 6379 for the port. Redis has a number of databases. I'm just going to use first one. Use whichever one you want. My password to connect to Redis is this secret over here. And then the queue name. The queue name is going to be the key that's going to basically be the list inside Redis. So this is what I chose to be the name of the queue. You can make it whatever you want. You'll just have to make the same configuration in your workers so it connects to the same Redis instance, the same database, and the same queue. So let's go ahead and do that right away. So here as well, I'll do a config.py. And then we'll paste that in as well. Okay. And let's put a carriage return at the end. Okay, so that is our configuration that we need. Now let's go ahead and start working on the main thing. And so the main thing is essentially the application that is going to push messages to the queue, right? So that's what we want to do here. So there's a few things that I want to do. And let me just copy this from the GitHub repo so I don't have to retype all my imports, but I'm going to need a few imports. And I'm going to write some helper functions as well. So let's go ahead and say Redis _db. And you know what? I'm just going to copy paste that as well. And I'll explain what the code is. Saves me typing and makes the videos a little bit shorter. So here, we're basically going to create our connection to the Redis database. So this is what it needs from the config, the host, the port, the database number, the password. The other thing too that I do here is I just make sure that Redis is actually up and running. So I ping it. If it fails, then my entire application will fail. You probably want to handle that a little bit more gracefully, but that's what I'm doing here. So this is going to be connecting to Redis. The next thing is I need to be able to push messages to the queue. So I'm going to write a little helper function here just to break out the functionality more than anything else. I really don't have to. You can see it's fairly straightforward. I need to know which Redis connection database am I using and what's the message, right? The queue name I know. I get that from my config. So this is where I'm going to push to the left of the list. So the way I'm thinking of my list as a queue in Redis is that the left of the list is the tail. So I'm pushing from the left and I'm going to pop, when I read the messages, I'm going to pop from the right. So here I want to do an L push, a left push. You also have R push, but that would then reverse how you think about your queue. So up to you how you want to do it. I'm thinking of my queue as going from left to right. I push items from the left and I pop items from the right. So that's all we need. That's it. That's all we need to push a message to the Redis queue. It's very, very straightforward. The rest of our application is essentially our code, our main, application code, and it might do a bunch of stuff. And amongst other things, it's going to create and push these messages to the queue so that they can be processed by the workers, asynchronously. So here, again, I'm just going to copy paste the code from the GitHub repo. And what do I have? Well, I've got my main routine, essentially my main function. And I'm going to take in the number of messages, which means how many messages do I want my application to create? Okay, so this isn't a real application. I'm going to mimic, something that creates messages. Here, I'm going to basically define as an argument, well, how many messages do I want to create? I'll come back to this delay in a second. So the first thing I do is I get my connection to Redis, and then I create my messages. This is just basically a Python dictionary. I have a message ID. It's always a good idea to include a message ID because you may want to, look at the messages and make sure that you haven't processed them before or reprocess them and so on. And again, you can look at the README file. I've got a lot more information in there about some of the stuff, including things like dead letter queues that you can use when your workers are having a problem with one of the messages. Maybe it's badly formatted. The message doesn't have the right data in it, or something happens. You can use things called dead letter queues, which allows you to push the messages that you can't handle to another queue, and then you would monitor that queue and get alerts. If it starts filling up, there's a problem, that you need to fix. Anyways, I won't get into that in the video. You can read up on that in the README. So we're going to store our message as JSON in that Redis list. So we're going to just use the dump s function from the JSON module to create the JSON equivalent of our dictionary. And I'm just going to print out to the console that we're sending message number 1, 2, 3, 4. I'll print out the message ID as well. And then I'm going to push to the Redis queue. Okay, that was that function that we wrote. And here what I'm doing is I'm introducing an artificial delay in how fast the messages are getting pumped into the queue. Part of that reason is because I want us to be able to run, this thing that generates messages, and then the workers that are listening for messages to come in, and that just basically keep running until a message comes in and then processes it. And so I want to be able to essentially slow down the message generation so we can see what's happening when we run everything. So that's all that is. And then finally, what I'm going to do here, I'm going to say if name, if dunder name equals dunder main, then we're going to run main, and I'm going to create, let's say, 30 messages with a delay of 0.1 seconds. Okay, so we might tweak that a little bit later as well. So that's the main application, right? This is the application that eventually in your, in your context would start sending messages to the queue. So that's what that is. Now we can work on the worker. So let's create a file. Let's call it worker.py. And it's going to be very similar. A lot of the things are going to be very similar. We need to be able to connect to Redis. So let me go ahead and copy this stuff. So we have the same code essentially that we had in the main app. We can connect to Redis and we can push something to the tail of the queue, so the left of the list. Why do I have this push method in the worker? I'm only popping. Well, it's because I'm going to simulate what happens when the worker fails, let's say, to process something, and it wants to re-queue the item, the message. It's saying, well, I can't process it now for some reason, but I think I might be able to process it later. So it puts it back into the queue, as opposed to putting it into a dead letter queue or just ignoring the message, which are, of course, two alternatives that are available as well. So here I just want to show you how to re-queue the item, essentially. So I'm going to need the push that we had in the main application, but I also need now the pop. I need to be able to pop an item. So this is the code that we're going to use to pop the item. So we're going to pop from the right. This is what our pop is. Our pop is saying, take this database, take the Redis database, take this queue, and pop an item from the right. The B, what the B does, it's called a blocking call. So what happens is that you can think of your queue and your workers that are basically grabbing messages from the queue. Well, what happens if there is no message in the queue? What should the worker do? Well, the worker should wait, right, until it sees a message that it can grab. And of course, this is for multiple workers. So what's going to happen here is that this call to pop an item from the right of the list is going to block until it has one that it can pop, okay? And Redis guarantees that if we have multiple workers all trying to pop from the right, only one of them is going to get each message. It's not going to, we're not going to get the same message pulled or popped by multiple workers that are running concurrently. Now, there are ways that you can ensure that. You can basically take a look at the message ID, and you can, once you've processed a message, you could write the message ID to another Redis database as a key saying, hey, I've processed this, and put maybe a time to live on there so you don't keep it forever. And then whenever you process a message, whenever you pop a message from the queue, you could check and say, have I already processed this message? Yes or no? And if I have, okay, well, skip it. It's already been processed. With Redis, you shouldn't run into that issue. With SQS, you will, because SQS does not guarantee that a message cannot be delivered more than once. So it's not something I typically use in the context of Redis, but it is something that I use all the time with SQS. So anyways, the idea is that we're going to block our pop until there is something available to pop. That's the idea here. So the next thing we want to do is to write our main application. So again, I'm just going to copy paste this. So main is what consumes the items from the Redis queue and processes the message. So we have to connect to Redis, and then we just run an infinite loop. This worker is just going to keep running until we, control C out of it, or if it's running inside a, Kubernetes node, then we shut the node down, whatever it is, or until the worker crashes. That can happen too, right? Depending on how you write your code. So we have this infinite loop, and we're going to pop an item from the queue. That's it. And then we're going to process that message. And once the processing is finished, it's going to come back and it's going to, again, pop an item from the queue or wait until it has one available to pop. So that's the main application. That's it. That's how I'm going to grab items from the queue. So now I actually need to write the process message. And here, of course, this is what your computational thing is, right? This is what you're trying to do. So actually, I'm just going to copy paste that as well. Let's not waste time typing. It's all in the GitHub repo that's linked below. So this is what process message does. Remember, this is going to pop a message from the Redis queue. What is that message? It's JSON. It's a JSON string. So we're going to now convert that message JSON string back to a Python dictionary. And of course, you don't have to use JSON. You could use other, serialization and deserialization methods. I just happen to use JSON because it's simple, but there are others available as well. So here all I'm going to do is I'm going to say, hey, the message was received. And I'm going to do whatever, computation I need to do. And that would be it. But what I'm going to do here is I'm going to add in this mimic, for processing errors. So I'm going to basically say, hey, once in a while, my processing is going to fail for some reason, and I want this to be a repeatable message. So I need to push it back to the queue. So I'm going to process my message. And if it fails, then I'm going to print out the message that I'm re-queuing it. And I'm going to push that message back to the beginning of the queue, to the tail, I should say, of the queue, right? The left side of the queue. And this is why I needed this function over here. If it processed okay, yeah, great, it processed okay. I'm just going to print out that it processed okay. Obviously, in your context, you'll have to implement the processing that needs to happen, and you'll have to implement what happens after the processing is complete. Do I write out to a database? Do I push to another queue somewhere else? Do I write out to a file system? Send an email? I don't know, whatever it is that it's supposed to do. And that's it. That's it for the worker that is now going to do the processing. So in my mind, this, first of all, is much simpler than trying to use the Python's, sub-processing. It's simpler. I don't have to deal with the complexity of that. And then secondly, it is highly scalable. I can scale this across multiple computers. So all that remains now is to actually run the worker. And it's a single worker. It's a single-threaded Python application. There is no async going on here. There's no multi-threading. There's no complexity, right? The complexity is grab an item from the queue and do your work and then rinse and repeat. So now let's go ahead and actually run this. So I'm going to bring up a few terminal windows because we're going to want to do that. And actually, I'm going to show you also how to call Redis or the Redis CLI. So this is in the README file. So if you look at the README file, I have under the section running things, we can get the Redis CLI. We can connect to the Redis CLI that's basically running inside our Redis container. All we need to do is run this command. We need to pass it the secret, right? We need to pass it the database number that we're looking at, which is 0. We need to tell it the host. Now the host is based on my Docker configuration, and the host name was Redis. And then we want to run this, inside the Redis container, and we want to run this application, Redis CLI. So that's what that does. So let's go ahead here and go to dev. Actually, am I in dev? Yeah, so I'm going to change to Python blog Redis. This is where I'm running my application right now, where I've got my code. And we're here, right? So this is the code that we have. We have our Docker Compose file, our app, our worker. Oh, and sorry, let me make this a little bit bigger, like so. All right, so we can go ahead and run this command, which I had before. Okay, so now I'm at the Redis CLI, and there's a few things that we can do. If we want to see all our keys, well, first of all, you could do a ping. You could see, the CLI is running, so you ping the Redis server, and it responds with that pong. So great, the Redis system is, the Redis server is up and running, but it kind of should be since we're running it inside that container. But things could go wrong and the container could still be running. So another thing that we can do, we can look at all the keys in this current database. So we can just say keys. I know it's customary to use uppercase. I don't. But anyways, this shows you that this database is empty. There are no keys in that database. So let's go ahead and let's make this a little bit smaller. And then I'm going to create a few more of these terminal windows. So let's do that. Let's make the font bigger. All right, so now I have all these different terminal windows. One is my actual Redis CLI. And then one I'm going to use for the main application. So let's go ahead and do this. And what I'm going to do here is I'm going to run my Python main app, right? If we look at that, we've got this main.py. So I'm going to run python main.py. What is that going to do? That's going to generate 30 items in the queue. I have no workers running right now. So as you can see, it's just sending the messages, and there's a little bit of delay. I put that in. So now if we look at our keys again, in our Redis CLI, you can see there's a key for demo 1. Now I want to list all the items in this key, and we can do that using this over here, lrange demo 1. So I'm going to go ahead and say that. So I'm going to say I want to look at the items in demo 1, starting at the first item and going up to the last item. This is like a slice. You can, of course, specify what slice you want. Here I just want all of them. So if I do that, you can see, and it's a little bit difficult to see like this. Let me try and make it a little bit bigger. Yeah, there we go. You can see that we have these 30 items in the queue, which were the items that we generated. And you can see that item number 1 is 29. Remember, you're looking at this queue where the tail is on the left, the head is on the right. So this is the tail. This is the leftmost element, right? That was 29. That was the last message that we created. The first one we created was this one over here. But again, remember what I said, your application cannot rely on the execution of these messages being completed in the same order as in which they were received. Your code cannot make that assumption. Okay, so now we have those items. Let's go ahead and actually run one worker. So here I'm going to switch over to the worker application, and this is the one that we have here. It's called worker. So let's say python worker.py. And let's go ahead and see what happened over here. So it received this message number 0, processed successfully, then message number 1, then 2, then 3. Now 3 failed, okay? And you'll notice what its ID was, and was message number 3. That failed, and it's going to re-queue it. Then message number 4 also failed, so it went to re-queue. Message number 5 also failed, so that went to re-queue. But it still continued processing the messages. Then it processed message number 6, 7, 8, 9, 10. Now we have a single worker here, and the worker basically is going to process the messages in the order in which they were received, because we just have a single worker. So if we go back, if we go to the very end, you can see that it did 29, and then it reprocessed 3, 4, 5, 16, which also had an error on the reprocessing, and then finally got it successfully. What you can do as well, some additional things you can do is you can try reprocessing the message, and then you can basically keep track of how many times you've tried to reprocess the message, and then say, well, if I've tried to process it 3 times and I failed 3 times, I'm done with it. I'm going to push it off somewhere else, usually a dead letter queue. So in things like SQS, that's actually a configuration that you can do on your message queue, where you can basically retry a certain number of times, and then the queue is looking at this and saying, well, you've retried this thing X number of times, it's time to get rid of it, and it can push it to a dead letter queue. But here we're using Redis. We don't have all that more complex type of processing built in. We would have to do it ourselves. Okay, so this was using one worker. So now what I'm going to do is so this worker is still running, by the way, right? If I go ahead and I run python.main.py again, it's going to generate those 30 messages. And you can see that the worker is now processing those messages as they come in. So what I'm going to do, and by the way, now if we look at the L range, that should be empty because our worker processed everything. All right, so now what I'm going to do is I'm going to start multiple workers. So I'm going to do the same thing. I'm going to do to worker, and I'm going to run the python worker.py. So this is going to sit there and listen, and I'm going to do the same thing here. Worker, and then python worker.py. It's just going to sit there and listen. Now what I'm going to do here is I'm going to go back to my main, and here I'm going to, let's say, create 30,000 messages, and I'm not going to put a delay. Now I don't care about seeing the delay that much. Well, actually, no. Let me show you this one. Let's do 30 messages, and let's do a delay of 1 second so you can see what's happening. So let's get all our terminals back. So now we have multiple of them running. Okay, let me just clear the screens. So we start with something fresh. Well, that looks fresh anyways. And let's go ahead and run python main.py. So it's going to generate those messages one at a time with 1 second delay in between. And watch what happens in the workers, in these ones over here. You should see the workers each picking up their own message. Okay, now because of the 1 second delay, you can see these guys are waiting, and at some point the message comes in and one of them gets it, and they're going to process the message. You see, for example, this one, this message number 9 failed, it requeued, and it was eventually picked up by this worker over here. So it's not necessarily the same worker that's going to pick up the message again. Okay, so we've generated all the messages, and we can check here to look at our keys or the L range, and we can see we have an empty array. So all the messages were processed. Now let's go ahead and change the main.py again for the main application. This time I'm going to generate 30,000 messages, and I'm not going to put a delay. So it's just going to pump them out as fast as it can, and let's see what happens when we do that. So again, let me just clear everything. So the worker here is still running, this one's still running, this one's still running. All I need to do is just generate my messages. And you can see that basically they're getting picked up by the workers. And that's it. That's how I distribute computation in a very scalable way using a message queue. Here, I just showed you a very simple Redis-based message queue, but you can use other ones like RabbitMQ, SQS, Kafka, whatever you want. Now, one thing I just want to come back to quickly is the possible enhancements, okay? So I talked about the fact that we should not get duplicate messages received by the workers. So if one worker picks up an item and pops an item from the queue, from the Redis list, another worker that's also requesting an item at the same time should not be picking that same one up. I haven't encountered that, but maybe there are race conditions that could occur. So what I would do there, and I do it when I use SQS or ElasticMQ, is I will actually take the message ID and put it into a different database somewhere in Redis to say I've processed this message. And then when I pick up the message in the queue, before I process it, I check to see, have I processed this one before? If I have, just skip it, just ignore it, right? So you could do something like that. The other possible enhancement is using a dead letter queue. I kind of talk about what the dead letter queue is further up in the document, but basically it's a way to take messages out of your queue and putting them somewhere else so you don't lose them, but you can't process them anymore. You're done with that message. So you'd use a dead letter queue for that, and then you would monitor the dead letter queue to see if it has any items, and then alert you if it starts having items in them. There is also the potential for a loss of message. If we go back and look at the code, where does that actually happen? Well, if you look at the main on the worker, what does it do? It pops the item from Redis. It pops the item from the queue. So at this point, that message is no longer in Redis. Suppose that now things fail when we process the message. Well, we've just lost that message, right? So either you have to be, and even then that's not sufficient, but you have to be really careful about your code here, making sure that your worker doesn't just die, right? You need to make sure that you write properly written code with lots of, try excepts and things like that so that you can recover from errors and not lose your messages from the queue. And with simple workloads, that's easily doable, and I wouldn't then worry about it too much. However, if there is a potential where you could have a loss and you don't want that to happen, and often that's the case, then you can look at the Redis documentation. There's a link right here in the README. And if we take a look at that, let me magnify this a little bit. There is a section here called Reliable Queue, right? It's a pattern, basically. And what it does is it keeps another queue it has a processing queue where you can keep track of what you're processing, and you use this move command. And the move command will not only return an item to you that you're taking from one queue, but it will also at the same time put it into another queue. So this is one way in which you can basically avoid this problem of losing messages. Instead of just popping, you do this move, and now this item is in another queue, and then you can check to see if that other queue has items. And if it does, that means that, because once you finish processing, you can now remove that item from the processing queue. So if your worker starts up and it can look at this processing list and say, well, wait a minute, I've got stuff in there. So you could do a variety of things. One of the things would be to basically move these messages that are in the processing queue back into the main queue, right? And this is where now you would probably definitely want to either have idempotent code where reprocessing the same message doesn't matter, or you'd want to keep track of it somewhere else, saying, I've already processed this message. Yes, it's in the processing list, but I've already processed it. I'm going to skip it, right? So basically, these are some of the things that you can do. It's very straightforward to do. Try it out. And as I said, if there's enough interest, I can do another video that talks about this specifically, or that talks about using SQS and so on. And that's it for this video. Thanks for watching.